Alright, so we're going to write this down. So we're looking at trigonometry. Now, so you did some review of this last week, and we're going to start taking it another step further. Every trigonometry that you've used so far has been for what type of triangles? Yep, right angle triangles. And we need to start looking at, well, what do we do if we are dealing with non-right angle triangles, okay? So there's a couple of different techniques we can use, but before we do that, we're going to look at the common trig ratios. So we're going to write down in any, so this is a little bit of review, in any right angle triangle, we'll draw a little picture. I'll just tidy this up. So let's say this is my angle, then this side is the what do we call it? What do we call this side? Alright, thank you. This side is the hypotenuse because it's opposite the right angle, and then the last side is the adjacent, okay? So in any right angle triangle, the sine of the angle is equal to opposite over hypotenuse. Cos of the angle is equal to adjacent over hypotenuse. So this is all stuff from last year. And tan of the angle, yep, opposite over adjacent. So these will be given to you in the formula booklet, so you don't need to remember them. And like I said, we did some review on that last week. Okay, so we're going to put, there are certain angles that we must know sine, cos, and tan of. And those angles are, they are, well, yeah, so actually I'm going to give you them all. So 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, so we must know, say, sine of 60 degrees, cos of 60 degrees, sine of 45 degrees, and tan of 30 degrees, okay? We must know all those, like sine, cos, and tan of all of these angles. Now, we can obviously put them into our calculator, but we must know them as exact values, okay? So the ones we're going to focus on today are these ones. 30, 60, and 45. Okay, we'll do the other ones later. Alright, so in order to find sine, cos, tan of either 30 degrees, 60 degrees, or 45 degrees, we must remember two important triangles. So I'm going to show you two different triangles, okay, that are going to help you remember what sine, cos, and tan of 30, 60, and 45 are, okay? Now, you can either remember the triangles, okay, or you can just remember, okay, sine of 30 degrees is such and such, or cos of 30 degrees is such and such, okay? I don't care how you remember it. I just like these triangles because if you just remember those, then they give you all the information you need, okay? All good? All right, so the first triangle, can I move it down to here? Okay, the first triangle is an isosceles triangle. Okay, it's going to be right angled. Yep. Sure you can. Isosceles just means two sides are the same. So if this is my right angled isosceles triangle, then I'm going to say that this side is the same as this side. Okay. So I'm going to say that this is side 1 and this is also side 1. Okay. Now if this is isosceles and this is 90 degrees, Tyler, are you with us? Then what are these two angles?
The same.
Right, and they have to be 45 degrees. Make sense? So this is where I'm going to get my information for sine, cos, and tan of 45. Now, if this is 1 and this is 1, then what is the length of this side? Not 2, but square root of 2. How did you work that out? Yeah, what method? Pythagoras. Okay, so yeah, 1 squared plus 1 squared is 2. And remember then you have to square root to find out the other side. All good? So looking at this, what is sine of 45 degrees? Hands up. What is sine of 45 degrees? Yep, Jake.
1 divided by the square root of 2.
Right, 1 divided by the square root of 2. Okay.
Is there a relationship between the sines, cosines, and tangents of like 45, 60, like 30? Is the sine of 30 half of the sine?
No, it's not. That's a good question. We'll come to that in a second. What about the cos of 45 degrees? Sorry?
1 over square root of 2.
Why?
Because you're adjacent
Yep.
side length over your hypotenuse side.
Right, good. Okay, so remember, if I'm looking at this particular angle, this is my opposite, this is my adjacent, this is my hypotenuse. Cos of 45 is adjacent over hypotenuse, so it's also 1 over the square root of 2. Somebody else, what about, don't shout out, just put your hand up, tan of 45. Frankie? Yes, just 1. Opposite over adjacent, 1 over 1. which is 1, okay? Now, if you remember this triangle, you will be able to get these no problem, okay? And I know that it looks like it's fairly easy to remember, but people get confused with these because, you know, you also have to do sine, cos, and tan of 60 and sine, cos, and tan of 30, okay? And you don't want to be making silly mistakes on it. Now, I said that this was 1 root 2. Does it matter what these sides are? No, because what's going to happen, it's going to simplify to give you these particular values, okay? So sine of 45 is always 1 over root 2. If you put that into your calculator, what do you get? Yeah, you get a lot of decimals. Let me just quickly load this up. DI83. If I do that, so sine of 45. Okay, I get 0.8509, okay? So, is this number exact? No. Is this number exact? Yes, okay. 1 over square root 2 is exact, okay? What type of number is 1 over square root of 2? It's irrational, good, which means it goes on forever. 1 over the square root of 2, hopefully I get 0.85 and so on out. Where's my square root button? Second. Uh-oh. What have I done wrong? Uh-oh. Actually, I'm in the wrong. Okay, so we need to be in degrees. Alright, we'll talk about degrees shortly, okay? Sine of 45, 0.07, okay? It's the same as 1 over root 2. All good? Okay, good. Right. So that's your first triangle. That's our 1 root 2 triangle. The second one, I remember it by thinking of it as a equilateral triangle. So let me draw this first, and then you can have a look. Oh, come on. Computer. So if it's equilateral, like this, and I'm going to say that all the sides are 2. I was going to say 1, but let's say 2, 2, 2. I could actually say 1, but 2 just makes it easier in terms of simplifying. What are the angles of each of these? Yeah, they're all 60 degrees, okay. Now I'm going to drop a horizontal. And when I do that, I've made it into 2 right angle triangles, yep. Now if this is 60, what is this angle? Yeah, this has to be 30, okay. And I have cut this line smack bang in half, so this side is 1. So you can see where I'm going to get my information from here. So that is 1. Now, if this hypotenuse is 2 and this side is 1, you can tell me what this length is going to be. What's the length of our height? Okay, good. So you got your square root 2 squared minus 1 squared. So that's 4 take away 1, which is 3. Square root it, yep. This is the square root of 3. So you only really need to remember this half of the triangle, okay? I just prefer to remember it's a 2, 2, 2 equilateral and then just fill in everything as I go, okay? Yep, Darius? You alright? Alright, so what's sine of 60 degrees? Hands up. What is sine of 60 degrees going to be? Hands up. Someone other than... Yes, Tyler? Yeah, opposite over hypotenuse. square root of 3 over 2. What is cos of 60 degrees going to be, Samara? Cos of 60. Yep. Yes. Good. What is tan of 60 going to be, Sam?
Root 3 over 1.
Yep. So just root 3. Good. So those are our 60s. What about 30s? What about sine of 30, Jake?
Oh, sine of 3 would be 1 divided by 2.
Right. 1 divided by 2. What about cos of 30, Jesse?
I don't know how to do
It would be 1 divided by 33.
Be careful. So cos is adjacent over hypotenuse.
Oh, 1 divided by 3.
No. Take your time. So there's my 30. This is the opposite. This is
33
yep.
divided by 2.
Yeah, square root of 3 divided by 2. What about tan of 30? Someone else to shout out. Yep.
Is square root 3 divided by 2 equals square root of 5?
No. Because you would do your square root part first and then divide by 2. Yes, Tyler?
1 over the square root of 3.
Yes, 1 over the square root of 3. Alright, so hopefully you can see that it's very easy to get these things confused because there's a lot of things that look the same here. We've got 1 over 2, we've got 1 over the square root of 2, we've got square root of 3, 1 over the square root of 3, the square root of 3 over 2. You know, there's a lot going on, okay? Now, I don't mind, like I said, if you want to forget about these triangles and just remember this. Now, you do need to remember it, okay? That's absolutely fine, but I quite like the triangles. I encourage students that whenever you go into the exam, the first thing you do is to draw out these two triangles, okay? So you have them there right in front of you, and then you can pick off easily, okay, the sine of 30 is 1/2, or tan of 60 is root 3. I don't remember these things, okay? I'm pretty useless at it. If somebody says to me what's sine of 60, I kind of have to go back and think of what the triangle is, okay? But it may be the case that you can remember this quite straightforwardly, okay? But you do need to know it. Remember this, you do have a non-calculator exam, and you will need to use these, okay? All good? Straightforward? Excellent. Let me just stop this for a sec. Alright, so John is flying a kite. The kite string has an angle of elevation of 60 degrees. If John is standing 30 meters from the point on the ground directly below the kite, find the length of the string. Now, any type of trig question, okay? You see 60 degrees, 30 degrees, 45 degrees, whether it's calc or non-calc, you should be thinking exact values, okay? You should be thinking of these values that we have just done, okay? To go about answering this, what's the very first thing that you should do? Yeah, draw out a little diagram, draw a little sketch, okay? So we've got, imagine there is the kite string. We're told that it's a distance of 30. We're told it's an angle of elevation. So remember, angle of elevation is if you're looking horizontally and then you like look up. So this is 60 degrees. And what are we trying to work out? Yeah, which is the hypotenuse. Good, which is this one. Alright, so we can label our triangle. Actually, you go ahead, do it, and then I'll just do the solution. I want an exact value, okay? So no calculators. So we labeled it. Cosine 60 equals 30 over x. How do I go about rearranging this for x? Okay, good. I like this idea of doing this, okay? You work through it systematically, okay? To find x, x is on the bottom. To get rid of it, multiply. So I get multiply both sides by x. X cos 60 equals 30. Then to get x by itself, divide both sides by cos 60. So I've got x is equal to 30.
And since we know cos 60 is equal to
Cos 60 now, yep, so I'm not expecting you to remember them now, but next time I see you,
Half.
cos 60 is a half.
So 30 divided by half is 60 and 2.
Right, 30 divided by 1/2. Remember, that's the same as 30 times 2/1. Keep change flip. The length of the string is 60 meters. Yes, Mara.
Realistically, the ratios, if you look at your triangle and you see that the
Yes.
opposite side to x is 1 and then the side to x is 2 and you can just times both.
Yeah, in this triangle, 60, 30, 90, okay? The adjacent, or sorry, not the adjacent, it depends which angle we're looking at, but this side is always going to be half of this one, so, and that's exactly the same case here, alright? This one is half of the hypotenuse, yeah. Yeah, Marco?
Yeah, the way the triangle is drawn makes it not look like it's so because the
No.
triangle looks really flat. But if that angle really is 60 degrees, then all the ratios of side lengths need to be the same to match
Yeah.
the angle.
Yeah, my diagram is not very accurate, yes. All good? Excellent. All right. Let me direct you to... Okay, so we've only got 5 minutes, but page 481 is what you can be looking at in the SL book. HL is a good idea to look at that as well, just for the practice. And then we'll do the area bit next.
Is that our quarantine one?
That's, yeah, if we are stuck at home, you can have a look at that. I will try and post a video.
So should we be like constantly watching Microsoft Teams?
Yes. Now you should set up your Teams so you have notifications set on. So
You can download it. I have it downloaded. It's recommended if you download
download.
it. Microsoft Teams.
Oh right, okay.
It downloaded itself on my desktop, and that's how I knew about it already.
Okay, good.